Welcome back, guys, to my videos. Today we're going to be talking about capacitors. I know I've been gone for a while. It's probably been a month, but I think I have something to make it up for you guys. So I've been working on a couple things, and they're irrelevant, so we're going to get on to capacitors. Also, I believe I'm going to be doing inductors next video because, they're kind of here, I'll just explain them. So capacitors don't like change in voltage, and inductors don't like change in current. That's the main difference between them. And yeah, that's pretty much it, guys. I'll show you how they work, but this video is dedicated to capacitors mainly. So mainly, it's dedicated to capacitors. So let's get on with it. So I believe this. We're gonna be using our meter. I don't know if you can see it better. Maybe like this. Sure. Why not? So let's not short this battery. Not good, yeah. So the battery measures about 8.29 volts. So we're gonna use 8.29 volts. Right. This is just our mark. And what we also will be doing is I'm going to be explaining, actually. You guys won't be doing anything besides watching. Maybe taking notes, who knows. And so capacitors, there's quite a few variety of them, but main separate groups is polarized and non-polarized. Or electrolytic, non-electrolytic, does not matter. This is easier to say, and also probably easier to remember. So polarized means it has a polarity, plus and minus, and this doesn't. Now, there's a few varieties, but the most common ones are polarized capacitors, which are these guys. You might have seen them. And I have a couple of them here. And it's not this fat, it's a straight one. So, there you go. Now, how you could tell the difference, like, let's say, not tell the difference, how you could tell which one's negative, which one's positive is by the short rod, or on the capacitor, it usually says over here, minus. You can see a little tag. Other sides don't have it, it's only the one. It's only the negative one, so I'll show you this is the negative rod. So like, let's say if you have an equal lead, actually I've been calling it a rod, equal lead. You can't tell the difference. Yeah, you could just look on the capacitor. And yeah, that's pretty much it. So you could see like a little minus. Sometimes it's like this. And non-polarized capacitors. Let's see if I have any of them here. Yes, I do. So these guys are like one of the most common ones. They're called ceramic capacitors. And then there's another variety which you might see, film capacitors, and the Sharpie is running out of its thing. Not like this big. They're pretty fat, chunky ones. I don't have those, sadly. Next thing is farads. Farads is a SI unit for capacitance. So, my God, I'm losing my mind. So you could see right here the symbol micro. Whoa, like the U. Come on. Yeah, there you go. 100 microfarads. Again, here. Capacitance, okay? So, the more farads a capacitor has, it means its ability to retain the voltage it's giving is much stronger and will withhold it for much longer. So let's say we're putting off 100 farad compared to 22 microfarads. So 122 microfarads. Who do you think is going to win? If you pick this guy, you're correct, obviously, because it's higher.
Well, duh.
Now we have two capacitors, right? Now let's say this is our 100 microfarad and our 22 microfarad. What you're basically doing is creating one big capacitor. Now these guys will be about 122 microfarads. Yeah, I'll let that sink in. Alright guys, so on my drawings, my schematic wasn't very well presented, so I made one on everycircuit.com. And here I'm showing you how this circuit works. So we're using a 9 volt 220 ohm resistor, normally open button, 22 microfarads capacitor, electrolytic, and a LED activated 2 volts, so it takes 2 volts to activate it. The 220 ohm resistor is there to protect the LED and affect the RC time constant, which is a resistor and capacitor charge and discharge. Then you could see me adjusting the microfarads. So now if it's higher microfarads, it'll take longer to charge up the capacitor and longer to discharge when you see me let go of the switch. What I forgot to tell you guys is when the square waves that are generated from the button, the capacitors do this thing. You see that blue line? It's creating this like ocean wave because it's smoothing it. So the square wave, when it's pressed at the start, it starts to climb up slowly, and then when it's released, it goes down slowly. And then you could technically fine tune it if you have a certain amount of resistance and capacitance together. You could technically create a sine wave with it, which is how I did one of my projects, converting DC to AC, but I'll show that later on. So this is where RC circuits come into smoothing, and that's what capacitors do in circuits. They smooth things out. So now it's not as jagged as a square wave, it's more of an ocean wave. That's capacitors for you. Nothing too crazy, and it's an 8-minute video, so makes this a perfect little showcase. And hopefully I'll post the next video in about 3 days, which will be about inductors. There's not a big difference, except like I said, inductors don't like changing current and capacitors don't like changing voltage. See you guys in the next one. Bye bye.